students, good morning. You are welcome to our online education of New Satyam Catholic School. How are you students? I hope so you must be safe and fine at home. Before starting our study session, students, you have to answer a riddle, a small riddle. Okay, let's go now. I came in many shapes, size and colors. I stick to many surfaces, but I am in fact not sticky at all. What am I? Answer of this riddle is connected with our lessons. So, answer to this riddle fast. Yes, you are right. It's magnet. So, today we have to begin with our chapter number 15. The chapter number 15 is related to magnet. Students, this is a small poem related to magnet and I will be singing it for you. I am a mighty magnet. I can be very strong. But if you use me exactly right, nothing can go wrong. I can pick up many objects, but not everything you see. I only pick up objects that are attracted to me. Oh, that are attracted to me. So take me now and try me out. Take me now and try me out, and you will be quickly see. And you will quickly see what different kinds of things, are pushed and pulled by me, I am a mighty magnet. I can be very strong. But if you use me exactly right, nothing can go wrong. Student, how was the poem? Nice, no? So, this topic is related to magnet. Fun with magnet. Chapter number 15, Fun with magnet. Hence, there is story behind the magnets. So, let's know the story. Students, the story of magnet goes like this. There is a legend about the discovery of magnet. It is said that a shepherd named Magnus lived in Greece. So, what was the name of the shepherd? Magnus. And where did he live? He lived in Greece. Once, while his sheep were grazing, he sat down on a big rock. So, students, where did the shepherd sit? Where did he sit down? On a big rock. But what a surprise he got when he tried to get up. His staff and his shoes were stuck to the rock. What was the surprise? That his staff and the shoes were stuck to the rock. He had to use a great force to pull himself away from the rock. He realized that what had happened was because of the iron ferrule on his staff and iron nail in his shoes. However, other rocks did not stick to his shoes or staff. Later he showed the rock to everybody. ठीक है, समझ में आया? कि सिर्फ उसके स्टाफ और उसके नेल्स वही उस रॉक को अट्रैक्ट हुए या चिपक गए, स्टिक हो गए. Whereas अदर कुछ भी स्टिक नहीं हो रहा था. And same thing is not happening with the other rocks. And he showed the rock to everybody. The rock was named as magnetite after Magnus. तो magnetite क्यों नाम पड़ा? Magnus के कारण. Magnus the shepherd. Magnetite is a natural magnet, and it also possible that the name magnet come from Magnesia, a part of Greece where magnets were discovered. Magnetite is a natural magnet. Magnet attract magnetic material. It attracts material like iron, nickel, cobalt. These are called magnetic material. Material that are not attracted towards magnet are called non-magnetic material. Each magnet has two magnetic poles. It has two magnetic poles and they are north and south. A freely suspended magnet always lying in north and south direction. Opposite poles of two magnets attract each other, whereas similar poles repel each other. I repeat, opposite poles of magnet attract each other, whereas similar poles magnet repel one another. Hence, this is the definition of magnet given in your textbook. Material to which objects made from iron, nickel, cobalt, etc. get attracted is called magnet. Material to which object made from iron, nickel, cobalt get attracted is said to be a magnet. This property of a material is called magnetism. इसी को हम magnetism कहते हैं. So let's look at some of the objects in which magnets are used. Student, here is a picture of pin holder. Pin holder देखा है ना सबने, उसमें magnet use किया जाता है. Magnet is also used in refrigerator door of a cupboard or drawer, and music system like speaker. So magnets are very useful to us. So it is very important for us to know their property and also the power of the magnet, the magnetic field, etc. In this lesson we are going to study about magnetic property and what else we are going to study about how magnetism is destroyed, what should be done to make the magnetic power lifelong. So here we are going to see some of the properties. Okay. These are the pictures of rock or magnetite from which the magnets are made. Magnetite is a natural magnet. We are going to see different types of magnet. Bar magnet, disc magnet, horseshoe magnet, ring-shaped magnet, cylindrical magnet, and also small button magnet are the different shape of magnet in everyday use. Here you can see various type of man-made magnet. This is the horseshoe, bar magnet, then button shaped magnet and ring shaped magnet, and students, the north and south pole of the magnet are painted with red and blue color. It will help us to know that which side is north and which side is south. Magnets are made in several shapes, including bar, horseshoe, ring, disc, and cylinder. Magnetism works in a different way around each shape of magnet. We use bar magnet in compass, horseshoe magnet in small electric motors, and disc magnet in radio, television, or stereo, that is loudspeaker. Bar magnet, ring magnet, horseshoe magnet, and cylindrical magnet. The picture also gives you the types of magnet. That is, they are somewhat same as the previous one. Round magnet, horseshoe magnet, rod shape, then flat and bar magnet. Students, here two different magnets are seen. Which are the two different magnets? Disk magnet and magnetic needle, which has been used in mariner compass. What are magnetic material? Those material which get stick to the magnet are magnetic material. Students, you can see how iron filings are getting attracted to the magnet. So, iron filings are the magnetic material. And the materials which are not attracting towards magnet or not sticking towards the magnet are non-magnetic material. For example, wood. Wood is non-magnetic material. Have you ever seen wood is getting attracted towards the magnet? No. Why? Because wood is not a magnetic material. Next, you can see iron. 1 rupee coin. It easily gets stuck to the magnet. Why? Because they are made up of magnetic materials. When a magnet attracts an object, the object gets displaced and get attracted towards the magnet. Due to the magnetic force, a force is exerted by magnet on the object, and that is why the object gets stick to the magnet. Is that clear? In place like factory, port, garbage depot, large objects are shifted from place to place. For this purpose, crane with magnet are used. Work is done by magnetic force, and this shows that magnetism is a kind of energy. The work is done due to magnetic force. That is why it is said that magnetism is a kind of energy. Let's look at the characteristic of the magnet. The first characteristic of the magnet is magnet always settles in north and south direction. Determine the direction in a class or laboratory. Tie a thread to the center of the bar magnet and hang it from a stand. Note the direction in which the magnet settles and turn it around again. Let it settle and note the direction. Do this many times. What do you observe? It will settle in only north and south direction. First characteristic property is magnet always settle in north and south direction. Second is magnetic force is concentrated at the two poles of the magnet. Where is the magnetic force is concentrated at the poles of the magnet. Ends of a magnet that point to the north is called north pole, while the end that point to the south is called south pole. The north pole is indicated by N and south pole is indicated by S. Place some iron filings on a sheet of paper and pass a bar magnet over them. Pick up the bar magnet by holding it in the center. What do you see? To which part of the magnet do most of the iron filings stick? On which part of the magnet do we see few iron filings? What can we conclude from this? We conclude that the magnetic force is concentrated at the two poles, that is two ends of the magnet. If a magnet is divided into two, parts, two interdependent magnets are formed. It means the two poles of the magnet cannot be separated. If you try to separate the two poles of the magnet, it can never be separated. Take a bar magnet that can be cut with scissors or a knife. Take iron filings on the sheet of paper and place the magnet on it. Most of the iron filings will be seen to stick to its pole. Now cut the magnet into two pieces as shown in the picture and place those pieces on the iron filings. Pick up each of the piece and observe them. What do you find? If a magnet is divided into two parts, two independent magnets are formed. It means that the two poles of the magnet can never be separated from each other. A magnet material acquires magnetism when placed near a magnet. This magnetism is called as induced magnetism. Fix a powerful bar magnet to a stand as shown in the figure. Fix an iron bar at a short distance below the magnet. Take iron filings near the iron bar. What do you see? After some time, take the magnet away. What happened now? Iron filing stick to the iron bar when the magnet is near it and falls off as soon as the magnet is taken away. That is, the magnetism in the bar vanish. It shows that magnetic material acquire magnetism when placed near a magnet. This magnetism is called induced magnetism. There is repulsion between like poles of a magnet while there is attraction between opposite poles. That is, like poles of a magnet repel each other and unlike poles of magnet are attracting each other. That is, if we bring north and north pole of two magnets together, it will not attract, it will repel. It will repel. But if you bring north and south pole, that these are the two different poles of the magnet, it will get attracted immediately. Fix a bar magnet to a stand as shown in the figure. Let it become steady. Take another bar magnet near the hanging bar magnet. Observe what happens. Do the same again and again and exchanging the ends of the magnet. What do you see? There is repulsion between like poles of the magnet while there is attraction between opposite poles of the magnet. Students, here we have to make electromagnet. Electromagnet is a magnet that is a temporary magnet and it is made only when the current passes through it. Okay, so here an iron nail of about 10 cm length and 1 meter long insulated copper wire, a battery, cell, pin or other magnetic object. Wind copper wire around the nail as shown in the figure. Join both the end of the wire to the cell. Now take the pin near the head of the iron. What do you see? During the above activity, we saw that the pin stick to the nail. Now stop the electric current and see what happened. The pin sticking to the nail falls off. Why does that happen? Magnetism is produced in the nail due to electric current. When it is put off, magnetism vanishes. Such magnet is called electromagnet. This magnetism is temporary. Electromagnetism is used in many places in our day-to-day life. For example, it is used in instruments such as doorbell and crane. Magnetism is produced in the nail due to electric current. When it is put off, the magnetism vanishes. Such a magnet is electromagnet. Electromagnetism is used in many places in our day-to-day life. It is used in instruments such as doorbell and crane. On the other hand, magnet fixed to pin holder or door of a cupboard are permanent magnet. Permanent magnets are made up of mixture of nickel, cobalt and iron. For example, magnetic material that is alnico is mixture of aluminium, nickel and cobalt. Alnico is mixture of aluminium, nickel and cobalt. So this is the permanent magnet which has been fixed into the cupboard. Okay. Next, let's see in past. The British scientist Michael Faraday developed the technique of producing electricity with the help of magnet. Michael Faraday was born in the poor family. A young boy, he had to work with books bookseller. There he read many books and developed an interest in science. Later he went on to research at the Royal Institute in London. It is due to Faraday's research that today we can use electricity and magnetism in innumerable instruments in our day-to-day life. How is magnetism destroyed? Magnetism gets destroyed when a magnet is heated, thrown, knocked about or broken into pieces. Therefore, it is important to store magnet carefully. A piece of soft iron is placed in a box in which a magnet is kept. The bar of a soft or pure iron protects a magnet. Therefore, such magnet is called a magnet keeper. Students, I will read it for you. How is magnetism destroyed? Magnetism gets destroyed when a magnet is heated, thrown, knocked about or broken into pieces. Therefore, it is important to store magnet carefully. A piece of soft iron is placed in a box in which a magnet is kept. A bar of soft or pure iron protects a magnet. Therefore, such a bar is a magnet keeper. Students, understood what you have to do with a magnet in order to preserve magnetism? Improper handling of magnet will reduce magnetic power. Okay, so these things are necessary, that we should not burn or we should not knock down, we should not throw or broke the magnet into pieces. All these things should not be done in order to restore magnetism in the magnet. Okay. So with this, I am finishing up the lesson. Let's go for recapitulation. That is what we have learned from this chapter. Various scientists discovered the knowledge we gain about them. The various instruments or gadgets we develop with its help are all useful for the progress of man. They must be used for the good of mankind. We have to take precautions while working with electricity or with important devices. We must use them under the guidance of our elder. What we have learned: iron, nickel, cobalt are magnetic metals. Magnets settle along the north and south direction when suspended freely. Magnetism is concentrated near the pole. Magnetism is concentrated near the poles of magnet. The poles of magnet cannot be separated. Electromagnetic energy is used in our day-to-day life.